Hi guys, so today we will start with the new question number 9, which is to write a Python program to compute following computation on matrix. So we have to perform the following computation, which is addition, subtraction, multiplication and the transpose. So let's just copy this question and move to our text editor so that then we could code. So here I will just paste this question, save this file as question9.py. So let me just comment this. So then let's just discuss what are matrix and what are the different operations on that. So yeah, so basically as we are talking about matrices, so matrices are nothing but some set of rows and columns which have some numbers. So basically they are represented by the square brackets. So here we can give any elements such as 1 2 3 4. So this is one of the matrix, and here this is denoted by 2 cross 2. So basically this is the row number and this is the column number. So basically we represent this like this, and if we more need to represent this in notation format, what we can say is a of 1 1, a of 1 2, a of 2 1, a of 2 2. So basically here it is in the form of a of ij, where I is the row number, so I is the row number and j is the column number. So basically this is the basic notation for matrices and everything. So matrix can be of any size, so m cross n, or it can be a square matrix n cross n, or anyway. So let's just see a few examples and then see the following operations. So first of all, let's just choose yeah, so let's just take a square matrix which has 1 1 1 1. So basically this is a simple square matrix having all the values as 1. Then there is some rectangular matrix which can have 3 5 7 8. So this is yeah, just try to find out the size of this matrix. So what cross what will be the matrix, just think a bit. So here I can say this is 1 row, 2 3 4. So 4 rows and 1 column, so 4 cross 1, and this is 2 cross 2. Similarly, let me just take another 2 3 5 7 8 3 4 2 1 1 5 9. So just try to compute the size of this matrix. So here I can see this 1 row, 2 row, 3 rows, and 1 2 3 4 4 columns, so 3 cross 4. Yeah, so let me just check. Yeah, 3 rows 4 columns, yes. So these are the basic matrices. There are more types of matrices: identity matrix, or what else, square we discussed, upper triangular, lower triangular, and there are many types, but we won't need that all. So we will just compute the addition of two matrix. So for addition of two matrix, what we do is we most of the times we take a square matrix, but depending on the cases this may change. So m cross m or n cross n. So we will take a square matrix which should have a11, a12, a21, and a22. So these are the basic matrix. Then if we have a same size matrix, let's say a sorry let's just take this is b11, b12, b21, b22. So this is also matrix m cross m. So basically if we have these two matrices and we have to perform addition, so what we do is we take this first element, so we take the same elements from this as well as this, and we add. So we create a new array, sorry, new matrix of same size m cross m, and we basically do is a11 plus b11, similarly a12 plus b12, then a1 sorry a21 plus b21, then a22 plus b22. Like this we perform the addition. So similarly we can also perform on various matrices the same addition. So if there is a multiplication, then we just do the same. Instead of plus we use minus. So we basically subtract the values. In mathematics it is kind of a bit different, means we can perform the same operations, but it is defined, this operation is defined some using some various other theorem. So basically what they do is they take this matrix as it is and they negate this matrix, means basically multiply by -1 to each matrix, and at last they sum both of the matrix. So that give the same value which we are computing, a11 minus b11. So let's just try to perform this, let's just try to implement this code. So here we are back, and what we will do is basically we saw a single row. So this single row can be stored as an list. So what we can do is this looks something similar to 2D array. So if we take this as an list, and then this as an list, and this as an complete list, so this looks me as 2D array or 2D list. So in Python we can call this as list. So we will create a 2D list in which this will be this is how we will create this. So let's just create the matrix at first. So let us take m1, and it would be a matrix, and 2D matrix of let's say 2 comma 3, and then another value would be I will do just a bit of indentation. So then the next value would be 4 comma 5. Similarly I will also create another matrix which would be m2. So yeah, so then what we will do is we have to basically perform addition. So what we can do is, if I know the row and column value of this, so if I somehow if I somehow manage to traverse like this, so first this element, then this element, then this, then this, so kind of, then what I can do is I can just go on adding this m1 plus m2's that index value. So basically what I wanted to explain is let me just create a representation. So 2 3 4 5, so this is the basic list. So what I know is this is first element, it is represented by 0th index. This is second element, this is represented by first index. Similarly if I say in just this list, so what I can say is this is 0th element, this is first element. So this is basically column, and this is basically row. So if I know row number and column number, so 0 and 0 will give me this element. Let me just change this color. So 0 and 0 will give me this, 0 and 1 will give me this, then 1 and 0 this, and 1 and 1 this element. So basically I know how I can go from 1 to 0 to n, and then again I can implement 0 to n. So like this we can use two loops to iterate to various values. So I'll use this same loops and perform the calculation. So here now we are back to implementation. So for I in range, what we will take is, for now we will take it as 2, and then for j, which is column number, for j in range, let's say 2, what we have to do is we have to basically take m1 of I comma j, sorry, not comma, this mat list representation. So basically m1 of I, so at the first case it would be 0, so m1 of 0 would give me this list 2 3. So from that I have to choose the 0th element, which is 2. So basically like this we can access 2D arrays, and similarly as I access the elements of m1, similarly I will access the values of m2 also, and I will store this in answers ij value because the locations are same for each list. So first of all I would need to create this answer. So answer is equal to, we have to create a list, so I will just use list comparison to create this for I in range and 2. So basically this will create this list 2 times. So basically we will get something like this. Just a second, I will show an representation. So like this it will create. So if I indent it correctly, so this is how it will look. Just a second, yeah, this is how it will look, 0 comma 0. So this is the same matrix size as of we have considered for m1 m2. So now this should work fine. Let's just try printing the answer. So let's just directly print a and s. So if I execute this, so here you can see now 4 6 8 10. So how did this come? 2 3 2 plus 2 4, 3 plus 3 6, 4 plus 4 8, 5 plus 5 10. So yeah, like this we can create. And if you want to make this a bit user friendly, then what we can do is we can use inputs. So let's ask the row value. So row equal to input, we have to convert this into int. So input enter row value, so row count. Similarly we will also ask for column count, so that we can create any array of any row column size. So column, and here also column. So he will input this, then we have to use a for loop for I in range 2. So we'll take 2 matrices, and instead of I we can take underscore also. So why am I basically taking underscore is I am not going to use this underscore value, yeah, or what yeah, we will use maybe. So I will take this as n. So print, so what will we print is enter data for matrix, let's say n plus 1, because n will be 0 and we need to start from 1. So enter data for matrix 1, and we will ask for input. So for I in range of row, so we will loop through row, means if his user has provided 2, then we will loop 2 times. If he has provided 3, then 3 times. Similarly for j in range, let's say column, and what will we do is, so let's just print a new line here before this. So this will be printed in new line, and we will then print or we will then ask for input. So first of all we need to create an array of that size. So instead of creating 1, we will create 3 arrays. So m1 equal to these zeros. So here also, so let me just create this stepwise. So this is a list, so we have to use list comprehension. So I will use 0. How many times I need 0? Column number of times. So for I in range col, column number of times I need this 0 in this list. Similarly now I need this row, this is a single row, so I need this row how many times? So I need this row for I in range row number of times. So this should create an m1. So I will similarly copy this and paste for 2 times, one for m2 and one for answer, because answer would also be of same size. So m2 and then answer. So yeah, these are the main three matrices. So then after taking what we can do is, yeah, so let's take here if case. So we have to put this value into matrix. So what we can take is if n is equal to 0, means we are looping through first condition, then we will take matrix equal to m1. So basically what I am trying to do here is, so now I will take input. So where should I store? Should I store in m1, m2 or answer? How will I know? So for knowing that, I have created this condition. If it is 0, we will store it in m1. If it is 1, so else what we will do is we will store in matrix equal to m2. So now you would be confused, why will we use matrix? So here we don't know will m1 come or m2 come. So what we can do is we can just put a matrix name, and this will automatically refer to m1 or m2. So here similarly m of I, m of j equal to int input. So int input, and we will put enter value for let's say row I plus 1, because I is indicating the row count, and column j plus 1. So this should be a format string. Yes, so yeah, this should be something. So let's just try this whether it works or not. So enter row count, let's say 2, column count 3, 2 comma 3 matrix. So row 1 column 1. So here we should give colon and space. So here what I will give is 1, then 2, then 3, then again 1, 2, 3. So basically 1, 2, 3, 1, 2, 3. These are the values of my this. So I will now give 3, 2, 1, 3, 2, 1. So basically here you can see 4, 4. So I'm only getting 4, 4. Why? Because I have taken the range 2. So what I have to do is I have to remove this answer, and the range would be, instead of 2 it would be row, and here it would be column. So now this thing should work fine. So let's just try once. Enter row count, let's take 1 comma 2. So 2, 3, 2, 3. So here you can see 2, 3, 2, 3, 2 plus 2 4, 3 plus 3 6. So this is our matrix. So like this we can perform addition. So yeah, let me just comment it here. This is code for addition. Yeah, similarly now what I can do is I can just copy this, and or I will also copy this comment, and I will put this below with the subtraction. So there isn't any change, and we have to just change plus to minus. That's the change itself. So similarly what I will do, instead of now taking this input, I will just comment this out. So whenever we would need, we can access it. But for now, just a second. So 1, 2, 3, 4. Yeah. So yes. So we will directly take the values. So let me just copy this. So uncomment, and I will modify this to 3, or let's just copy all 3 and modify it below. So here I will add, and instead of this, what will I do is, let's just remove this code. So I will put and 2 comma 3, and then 4 comma 5, and similarly I will just copy this and paste it here. So instead of 4 comma 5, let's just take 8 comma 9, and here also 0 comma 0, so that we can directly see the values easily and we can compute it without checking what was the input, what was with the output, etc. So yeah, here maybe there are 3 brackets. This should work fine. So let's just try executing this. So there is some okay, so here we are using row and column, so that's making an issue. So row would be 2 and column would also be 2. Column is also 2. Let's just execute and this works. So here you can see 2 minus 2 0, 3 minus 3 0, 4 minus 8 minus 4, 5 minus 9 is minus 4. So like this we got the answer for subtraction. So either we can also print second subtraction, and similarly so here like this, and similarly here. So instead of 2 it would be 1 subtraction addition, and then answer. So let's just execute this again and we can see first addition, second subtraction. Yeah, this works fine. Now what we have to do is we have to go for multiplication. So multiplication and also the transpose. So before going to multiplication, what will we do is we will go to transpose and then come back to multiplication. So yeah, so let me just clear this and we will see what is multiplication. So let's assume you have an array 1, let me just take 1 2 3 4 5 6 like this array, sorry, matrix. So here we have 2 cross 3 matrix. So its transpose means basically we have to convert rows to column and columns to row. So this is n row 1 2 5, so I have to convert it as column 1 2 5. Similarly now 3 4 6 is also to be converted as column 3 4 6, and now this whichever new matrix we get is called as transpose of this matrix. So if this is A, this is transpose of A raised to power t, we call it as A raised to power t transpose. So basically here I can see we have to convert each row into column, but how we will do that? So what is basically, so a simple thing which I can notice is I can look through each row at first, just make it as column in, but how would I make? So that's the question. So let's take the notation form. So here let me just take a11, a12, a21, a22, a31, a32. So these are my basically 3 cross 2 matrices. So what I have, just a second, 3 cross 2, and so this is the 3 cross 2 matrix. So now what I have to convert is I have to perform the transpose. So I have to convert row to column, column to row. So if I convert row to column, what will it become? A11 and A12, then A21, A22, A31, A32. So here I can basically see that here is 1 2 and here is 2 1, here is 2 2, here is 2 2, here is 2 1, here is 1 2. So I can see places are switched. So row is becoming column, column is becoming row. So basically which we did similarly. So what we have to basically do is we have to first check row and column, and we have to create a empty matrix of column cross row. So we have to first create a matrix of column cross row, and then basically if we have any value of a of I and j, okay, so we have to insert it as a of j and I in the answer matrix. So we have to just switch the row and column indexes. So yeah, let's just try this. So in transpose, what we will do is let's just copy this thing only and we will modify that. So yeah, let me just paste this, space, transpose, copy, paste it here, change this number to 4. So now in the answer matrix, what we have to do is this transpose is performed only on one matrix. So what we have to do is instead of I and j, we have to put it in j and I. Okay, so everything remains same, just we have to change this, and we have to change the answer matrix. So answer is equal to the same thing we did, 0 for I in range column. Now it would be column, not the range, not the row. And then for, okay, so here was column itself, so now it will be row and this will be column. So for j in range column, so let's just check. Yeah, first was column, then was row. Now we have interchange, so now we have row and column. So basically like this we have to perform. So let me just try this and see. So first of all, okay, so what we are seeing is m1, m2, 2 and 4, 3 and 5. Where did it, okay, yeah, so let me just print the m1, m2 also. So print m1 and print m2. So this should give us idea, because I was seeing the this matrix, addition matrix, and I thought how this values changed. So m1 and yeah, so let's just save and execute. Here now you can see m1, m2, so 2 3 now become 2 4. So basically let me just show this. So this was 2 3 and this is 4 5. So what has become row to column, column to row gives me 2 4 and 3 5. So 3 5. So here you can see I am getting the same matrix m1. Similarly, if I change m1 to m2, I will get the transpose of m2. So let me just execute this, and I am getting so okay, I am not printing this, I have to print. So let me just remove this and print m2. So now this will work 2 8 and 3 9. So basically this would work on any row number, any column number. You can try. So as we created this code also to take any number input, this works fine. So then what we have to do is now we have to see the multiplication. So either you can wrap this up into any function also. So yeah, let me just check the question, what have they said. So write a Python program to compute. So they haven't mentioned any function, but if you just want, what I will create this transpose into a function. So yeah, let me just take this and define transpose and the matrix 1 m1. So it would take only one matrix, and then that's all maybe. Yeah, so let's just pass the row and column number also. So mrc, so r would be row, c would be column, and this also rc. And instead of m2, let's just take m only. And here instead of printing answer, what will we do is print the transpose function, transpose and M would be M1. Row number would be uh, just take row and comma column. So let's just compute, and it is returning nothing. At last we have to return. So return answer, and let's just execute. Here we can see the same answer, so nothing changed. Like this you can convert everything into an function. So let's just see how we can perform multiplication. So multiplication in matrices is a bit complex. So while understanding it is bit complex, but programming thing is kind of simple if you know how the things work. So let's just see how we can multiply matrices. So let's just take an example. So I will take an example 1 2 3 4 5 6, or what we can do is let's just take an array notation format. So a11, a12, a13, and then a21, a22, a23. Then let's just take second array as b11, b21, b23, and then b12, b22, b32. This should be 31. Let me just change this. b31. So here what happens is, so whenever we perform multiplication, let's just find the size. So this is 2 cross 3, and this is this is 2 cross 3, and this is 3 cross 2. So basically what we do is we check the number of columns in this first matrix is same as the number of rows in second matrix. So this is the basic thing, and if these are same, then only we can multiply. If this isn't same, then we can't multiply. So basically how do we do this thing? So let's just remove this at first and make some space for some things and see. So here would be our resultant matrix. We don't know the size now. I will explain how we can find the size also, but for now what we have to do is we have to consider the row of the first matrix and multiply it with the column. So basically a11 into b11, then plus a12 into b21, then plus a13 into b31. So this will be the first thing. So yeah, then the second value would be the same row will be multiplied by second column, so which is a11 into b12 plus a12 into b22 plus a13 into b22. Yeah, so a13, a12, and okay, sorry, ab32. So then yeah, this is the first case. So sorry, let me just take this, and it should be here. So just a second, it shouldn't be below this, it should be besides this, so it should be here. Let me just rearrange this. It should be something here. Replace isn't available, so I will put this here. What I can do is I can move this a little bit and then select this, reduce a bit, and then place. So now this should be mostly be visible. I will also reduce this, so you can see, and then these are the two elements. Similarly here also there are the two elements, which we have to find, but for analysis these two things are sufficient for now. What we will do is let's just find that out too. So A21, so now multiply this with this again. So A21 into B11 plus A22 into B21 plus A23 into B31. Okay, so we'll select this. Let me just again select and reduce the size a bit. So similarly we will have a copy just with some numbers changed. So yeah, A21, yeah, same. So A, instead of 1 1 it will be 1 2. So 1 2, and then this should also be 2, and this should also be 2. So here if we analyze this a bit, so let's just move this up a bit. Here we can see this is 2 cross 2 matrix, and similarly in the last case here we saw this 2 and this 2 wasn't considered. So we basically saw if these things match or not, first column number and second row number match or not. If they match, then we can multiply, and then these two numbers will indicate the size of the resultant matrix. Means after multiplication what will be the size of this thing. So yeah, that was it. So then here now what I can see is, here this first thing and the last thing remains the same. Let me just change the color. So here I can see 1, and here 1 remains the same. Here 1, here 1, here 1, here 1, 1 3. So the first one, and then the 3 1. So this one remains the same everywhere. Okay, similarly here also you can see 2 1 2 1 2 1, like this. So similarly you can see this pattern, just this value is changing, A11 B11. So basically this value is changing between the A's column value and B's row value. So here if I know these two are constant, so what I can do is I can store this in some value. So let's just say this is I value, just a second. So this is I and this is J, if we just assume, and then let's just say this changing value as K. So what I have to do is I have to change this K depending on the number of columns. So basically this thing, the common element, the common size which we are checking. So here we have taken symmetric matrix, we have taken similar matrix which gives us 2 cross 2 matrix. But what would happen if we remove this value? So yeah, if I just remove this, I can remove this, and what would happen is I would just get this first element. So I would just get this much value, so not this two. So this was now 1. So here you can see this is 1. So 2 cross 1, I will get 2 cross 1. Sorry, just a second. So this should be not, this will be removed. Just a second. If we remove this, so what will happen is this will be removed because the second column is removed. So if I remove this, so this will come here, this will be our new matrix, and here the size will be changed. It will be 3 cross 1, and our resultant matrix would be 2 cross 1, 2 rows 1 column. Yeah, so this is how this works. So here as I can see there is some k is between this value. So now this is, yeah, so this similar value which we consider at first, this same value is considered for the k. So first 1 2 and then 3. So maximum we can go up to this same value, and I and j can loop through between this 1 to 2. So let's just try this, and then you will get a bit idea about this. So yeah, basically I and j we can get using for loop. So I can get this using for loop, and I have to just use k for other thing. So let's just try to implement this. So what will we do is, let's just make some space, so we have some space to do our thing. So yeah, so for I in range, so first of all we were looping through the rows. So first matrix we were using row, so we'll use the row. Then for j it would be in column, so range would be in column, so call. And then so here let me just check. So if, so we'll only apply this if the column of this thing, first matrix, is equal to the, so let me just write, so column of first, so m1 column is equal to m2's row. So if this is the case, then only we will implement this. So basically this we can check, this is same. But for other cases, what will we do is m1, so I will take the matrix m1, and if I take the length, so we would need the length. So yeah, just let me explain this. So here if I consider some matrix, let's just say 1 2 3, and let's just take 2 3 5 and 1 2 3. So here can you see, mention the size? What is the size? It is 3 cross 1, and here it is 3 cross 2, sorry, 2 cross 3, 2 cross 3. So here this is a single list. Okay, so if I choose first element from this whole list, so let us consider this is as m2, this bigger list, and if I choose m2 of any value, so let it be 1 0 or any value from that list, and if I check its length, so what will this give? I am basically checking the length of this individual list. So this individual list will give me 3, which is the column number. Similarly, if I directly check the length of m2, so what will I get is, so I will basically check how many elements I have. This is first element, this is second element. So here I will get 2, which is row number. Yeah, so basically these are the two things, how we can get row and column. So we have to basically check the condition, so we can do that easily. So here if m2, so we have to check the column number, so length of m2 and any of the elements. So I will take the first element is equal to the length of m2, so instead of m2 this should be m1, and if this is the case, then we can print, let's just print multiplication possible, okay. So if this is not the case, then we will write it is not possible. So we'll just indent this a bit, and in the else we will write, we'll take this else a bit lower. So else what we'll write is print multiplication not possible, not possible. Yeah, so then what we have to do is, now we have I and j, row and column. So then for k in range, so we have to take this value. So either we can take length of m of 0, or we can take this value. So what we can do is we can take any one of them. So I will take length of m2, or also length of m2 is basically the column, this is the row number, so I can directly take row. So whichever we can take any of the value. So then what we can do is then I can use for no, now I have I, J and K. So what will I do is I will take the answer matrix. So first of all we would need to also update that answer matrix too. So answer would be so 0 for the number of columns in the answer matrix would be equal to the length of, so let me first write for I in range. So here the size would be the size for this thing, as we are taking row and column. So here what would happen if we calculate this using matrix, what we can do is length of what value, so basically second matrix column. So how do we get column? So m2 of 0. So basically like this we can take the value, and similarly this should be repeated how many times? For this list should be repeated for I in range, the length of m1 of 0, the number of times m1's row, so basically m1's row. So this much time this should be repeated, and then what we can do is answers I and J. So basically the I and J of this would be plus equals. So just a second, just be with me, I'll explain this. Y plus equals, and then m1 of I K plus m2 of into m2 of I K. So this is the basic value, and we will get the answer in this. So we will basically get answer. So this was the simple thing for matrix multiplication. Now multiplication, let's just first see this works or not, if there are any errors. If not, then we could continue with the answer. So multiplication possible, and it is 13 into 77. So basically m1 and m2 are so here 2 3 4 5, 2 3 4 5 and 2 3 8 9. So we will just calculate this. So let me just take 2 3 4 5 2 3 8 9. So basically this is 2 cross 2 and this is 2 cross 2. Okay, this same we can multiply possible, and our answer value would be 2 cross 2. So let's just make this a little bigger. So yeah, this is our value. So what we have to do, we have to take first value multiply by first column value. So 2 into 2 gives me 4. Okay, plus 3 into 8 gives me 24. Okay, so 3 8s are 24, 2 2s are 4. Then again the new next value would be, so here 2 into 3. So 2 into 3. Now why we store this in answer value? So as we saw in the code, we use answer plus equals. So answer of I and J plus equals matrix 1 of I and J and matrix 2 of I and J. So why do we use plus equals? Because first of all we store only this value 2 into 3 we store into answer. Then what we do, we plus. So sorry, this shouldn't be 2 into 3, it should be, just a second, so this should be, yeah, this should be 2 into 3. Sorry, I just got confused. So 2 into 3, and then plus what we are doing, we are multiplying 3 into 9. So 3 9s are 27. So like this we are doing. Similarly then 4 2s are 8, 8 plus this thing, 4 2s are 8 and 5 8s are 40. Then again 4 into 3, 4 3s are 12 plus 5 9s are 45. So this is the basic calculation, and this is how we do it. So row into column. So this is the answer. Let me just see. So 28, and this is 48, and this is 2 3 is 6, 6 plus 27 is 33, and 45 47 57. Maybe there is some issue. Answer is bit different there. Let's just see. So here where is the issue? M1 M2 length checking correct multiplication possible answer. Yeah, row column row. Okay, so here is the issue. So here we have used M1 I k and then M2 ik again. So this is not what we needed. We need M2 k j. So why do we needed this? Let's just see back in our code. So here, as we can see, okay, so we maybe remove that. So basically, if we take an example again, A12 and B11, B12. So what were we doing is multiplying row by column. So A11 plus, sorry, into B11 again plus A12 into B. So this should be 2 1. Yeah. So this should be 2 1. So this should be 2 1. So here we can see I and j are same. I and j are same. I and j are same for each thing. But here this k value differentiate. So here k value is changing. So here you can see k value is changing. So what we have to do is we have to keep a of ik into p of jk, sorry, kj, k and then j. So then we have to plus this to the answer. So we have to add this, go on adding this value to the answer. So this is why we need this change here. So first of all ik and then kj. So let me just execute this again, and here now you can see 28 33 48 57. So now we are getting the correct value, and this was all regarding question number 9. So basically multiplication, transpose, subtraction, addition. So